Hello Homo sapiens! Today I'll be talking about electromagnets. First of all, to understand electromagnets, we need to look at the magnet part of electromagnet. Magnets are things that can attract other magnets and also specific metals. The magnets have a north and south poles. Probably, as you already know, alike poles repel and different poles attract. And with this rule, we can look at the electro part of electromagnet. When we pass a current through a wire, there are two ways to interpret this current, which is conventional flow and electron flow. Conventional current or conventional flow is the electrons flowing from the positive end to the negative end. But electron flow is from the negative to the positive. I'll be using these interchangeably. To make an electromagnet, well actually, you already made an electromagnet, but it's super weak. This part right here, actually all of the wire, it is an entire electromagnet. Just a really weak electromagnet. To make this electromagnet stronger, because each part of the wire is just one circle. To make it stronger, we can loop the wire around into a coil shape. And now, instead of just being free, the magnetic field lines are channeled through this center area, creating a very strong electromagnet. And to make this electromagnet even stronger, we can add a metal core, usually iron, into the center. And this will just make the magnetic field lines able to pass through faster and easier. The difference between a permanent magnet and an electromagnet is very obvious. A permanent magnet is a magnet. You cannot turn it on and off at will. It's just magnetic. However, in an electromagnet, you can switch it on and off. You can click a button, it's on, and then click another button, it's suddenly not a magnet anymore. The electromagnets can be used for many different types of applications, such as induction cooktops. You can also use it as a solenoid for solenoids, and then if you want to get really fancy, you can use it for induction heaters, which basically work by the principle that if you switch the battery or supply current, the supply input, negative becomes positive and positive becomes negative, it will also switch the direction of the magnetic fields. So, the machine, an induction heater, works by switching these values really fast at a really short time. And this will cause any metals that is inside of the coil the atoms will shake around because the magnets are switching so fast, shake around, and then eventually the metal will melt. However, this is good. This is safer than a furnace or something, because even if you put your hand inside of the coil and turn it on at full power, you're not going to feel anything because the human hand is not conductive.